question here saying calculate the number of hosts /17 /17. I know that IPv4 it had 32 bits, right? And here he's giving me an address and he's saying /17. So first of all, before going further, what gonna be the formula that I have to use to know the number of hosts of something? The general formula. If, for example, I have 2 bits that I'm using for the hosts, how many hosts I can have? 2 power 2. Almost. Jagjit, think about it. 2 raised to n minus 2. Good, Mitwa, right? So 2 power n, but minus 2 here. Why minus 2? I'm dealing with the hosts here. Why minus 2? Broadcast and network ID. Good, good. As you can see here, so every time that, what I'm doing here? So every time that I'm having such a range here, starting from something, ending in something, what is the value, the addresses available that I can use for computers? They are all the addresses between the network ID and broadcast. So when I do the formula 2 power n, 2 power something, like for example, if I have 2 bits, right? So 2 power 2, so this is the host bits, I'm gonna have 4, right? So I have 4 probabilities of addresses, but I need to exclude the first probability and the last probability because they are network ID and broadcast. They are not valid for computers. Okay, so if I want to know what is the number of hosts that I can use in such a range, in a range, I need to exclude every time on this formula 2 power n, I need to do minus 2 at the end because I need to exclude these 2 probabilities, the first one and the last one, because I know that this one is network ID, I know that this one is broadcast, right? So the general formula when we are dealing with the hosts, it's 2 power n. What is n here? N is a number of bits of hosts. Right? Number of bits of hosts minus 2. So this is the general formula to deal with the host. 2 power n minus 2. Minus 2, I need to exclude the network ID and the broadcast if I want to know the valid address. Because here he's asking for hosts. Network ID, I can't use it for hosts. As an address, it's a network ID. The broadcast, it's general, it's for all the network, so I can't just assign it to a computer, to a specific computer. So these 2 situations of network ID and situation of broadcast, I need to exclude them out of my probabilities, right? So all the probabilities are 2 power n. N is the number of bits of hosts minus 2. Now if I want to solve this problem, now we go back to our question here, right? So I want to solve this problem. I know that I have 32 bits in all. Okay, 32 bits in all. And I have 17 /17. What this mean here? /17. What this 17 mean? Literally. Come on, guys. What does 17 mean? Subnet? No, no. /17. What this number 17 mean here for me? Class B with 1 borrowed bit. Yeah, it mean this, but the 17, the number 17, just the number. What this mean? This is n. Malhar, are you sure? This is the number of bits of network, not hosts. /17 This means I have 17 bits for the network. This means I have my regular 16 of class B. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. There you go. Right. So this means I have my 16 bits and I have one extra bit that I pushed. And after, I will continue with the rest bits here. So 1, 2, 3, 4, 1, 2, 3, 4. And the last 8, because I know that I have 32. This is why I put it 32 in front of you. Okay. 1, 2, 3, 4, 1, 2, 3, 4. There you go. This is not n. This is not the number of bit of hosts. Not at all. N is the number of bits of the networks. Here. Me, I need to know how many bits remain for the hosts to use my formula. The famous formula, remember? 2 power n minus 2. N is number of bits of hosts, the blue ones here. So to do that is 32 minus 17. 32 minus 17, because in all, I have 32 bits. I used 17 for the network. How many remain for the host? How many bits I still have to get to 32? All right, it's a 15. So my formula will be 2 power 15 minus 2. Okay. Now, if I do that, I will find something in here. Well, let's do it. 2 power 15. So 2 power 10 is 1024. Let's use the calculator quickly here. So 2 power 15 equal minus 2. So it's equal to 32,768 minus 2. I will end up with the 66, right? So this is the right answer, because this gonna give me 32,768 minus 2 here, right? So this one gonna give me this. So minus 2, I will end up with a 66. Okay, so it's really important to get the logic behind, right? Especially to you, Malhar, right? Don't be like a robot. N, this 17 is N. No. In my formula here, I'm looking for the remaining bits, not the bits of the network. What we said about our formula, it's the bits number of bits of hosts here, because I'm dealing with hosts. Okay, number of bits of hosts, because I'm dealing with hosts. So I need to find and figure out how many bits remain, not the bits that I'm using for the network. Got it? Good. All right. So first answer is 32K766. Calculate the number of subnet in a network /80. Same thing, just with logic here, right? /18. /18. This is class B, right? This is class B. So the original one was /16. How many bits I borrowed here from this class B /16 to /18? How many bits did I borrow? 2. It's not much, right? I was at 16, class B. I pushed 2 from the hosts to the there you go. So if I go to my address here, I got /16. Here is it. Here's /16. Now /18. So I took 2 more. I pushed them here, right? And I still remain with the rest here, 6 and 8. Right. Now, question simple. He's asking me here, not hosts, not whatever. He's asking me just what is the number of subnetworks. So how many subnet I can have if I borrow these 2 here? What gonna be the formula here? What is the formula? The general formula. that I can use? The general formula, mitwa, 2 power 2. Good. How did you get 2 power 2? So let's say, for example, it's 2 power m. What is m here? What is m? What's going to be m here? Rise to number of bits borrowed. That's perfect. Good. Good. Right. The bits we push, the bits that we borrow and push from the host to the network. Here I push 2, so my general formula is 2 power 2. Should I put -2 here, for example, or not? No, I'm not dealing with addresses. I'm not dealing with valid addresses here. Here I need to know how many time I splitted my network, right? How many time I splitted my network? 1, 2, 3, 4. Why here? Because I borrowed 2. You see, /18. I have 1, 2, 3, 4 new networks. So it's 2 power 2. That's it. There is no -2 now. When we deal with the subnets, the general formula is just 2 power n, so it's still n, but n here is representing the number of bits we pushed, or the number of bits of subnets. Okay, so here of course my answer gonna be the 4, right? 2 power 2 is 4 subnets. Calculate the number of subnetwork in a range of, not subnetwork here, sorry, it should be hosts, right? It should be hosts, not subnetwork here. Sorry for that. Staple. How many addresses we have from this one to this one? I'm not able to know how many subnets with just a range, right? So we have a range starting from 33 to 1 and getting till 10 to 33 to 54. So how many addresses we have starting from this address to this address? It's really easy. It's a 254 addresses from 1 till 254. Well, let's do it a little bit more complicated. What if I have here, for example, 37, and I will do this 0 and 255. And I will tell you how many addresses we're gonna have in this range here. How I can calculate this? Who can help me? Give me the formula. What I have to do here? You see, so from this address to this address, how many valid address I can have? I will tell you that this is a range. This is a range, or this is a network. And give me all how many valid address I have here. How I can calculate that? Come on, guys, it's not that complicated at all. Come on, simple math here. Simple math for kids. Come on, help me. Remember, seconds, minutes, hours, 60 seconds in 1 minute, 60 minutes in 1 hour. Right? Remember that. How I can do that? Help me. Come on, people. Come on. Just give me the I don't need the result. Give me the equation, right? 255 multiplied by 4. Jagjit, think about it. Almost. You are almost there. -1. -1 what? 254 times 5. Not yet. I repeat again, this is just one range, right? So this is one range. You guys are a little bit lost with the network ID and subnet. We suppose that this is all my range. So I start my first probability start here, start in this one, and end up with this one, right? No, Malhar, 255 times 4 minus 1. No. Okay. So every time, focus guys, because I didn't get any good answer here. Focus please. Every time that this number gonna increment, I told you, think about seconds, minutes, hours. Every time that this number will increment, how many did I loop here? How many did I loop here inside? Come on, easy one. Come on, guys. 255. You sure? I can go from 0 to 255. How many I have here? 254. Seriously. From 0 to 255, how many I have here? 256. Good. Camel deep, the saver. Right. 256, guys. I have 255 plus the situation 0. I have 256 probabilities that I loop inside to increment, like 60 seconds, and after I have 1 minute, I reinitialize, right? So every time this number increment, I already have 256 here. So it's 256 time. How many times this number increment? I have all the range of 33, 33, 34, 35, 36, 37. It end up with 37. So it's 5 time looping, right? 5 cycles. So it's time 5 here. And this is my first probability. So this one should be a network ID, and this one is the last probability. So this one should be a broadcast. So all this minus 2. This is my equation. 256 times 5 minus 2. Now, if you do the math, you're going to find the answer here. Of course, it's not here. I don't think that it's here, because I changed the question. The first one was really easy. The first one, 33, 33 here. Nothing changed. And from 1 to 254. So the answer is 254. But now, complicated like that, it's 256 times 5 equal minus 2 equal it's 2. Well, it's just an extra question, right? So no worry about it. Here is what you should find if you do this one, right? 1278. Okay. Calculate the IP range of the third subnetwork of this swash 26. Okay, let's do it properly here. So now, since you get some headache with your bits and bits and bits and bits and bit 0, bit 1, I will show you how to do things a little bit quicker, right? It's bugged here, so it's not working. Here we go. So I will show you how to do things a little bit quicker. Okay, let's say I have this network 32, and of course I will give you 2 other exercises to practice after with this method. Dot 0. So this is a general network here, and it's slash 26. Slash 26, how many bits I borrowed? How many bits I borrowed here? Slash 26. 2. So my subnet mask will be 8 plus 8 plus 8 plus 2. right? So it's gonna be 255, 255, 255, and 128 plus 64 because I have 2 bits here. 192, right? So you guys, we're gonna make some roles, right? Every time you're gonna deal with subnetting, the first role is to find what is the subnet mask. If it's not given, right? Maybe it's gonna be easier. They will give you the subnet mask directly. But if they give you slash something, whatever something, or a little bit more complicated after, it's gonna come back here. I will not give you slash or whatever. I will give you how many computer hosts I need in my network, and you're gonna find the bits that I have to borrow, and you will find the slash, and after you will find the subnet mask. So it's a little bit more complicated, right? So this is a VLSAM, and we're gonna talk about it in next classes, next lectures. But for now, easy, right? So I have slash something, whatever. I have subnet mask. All I need is that subnet mask. This is the first step. So first step, I generate my subnet mask. Okay? Everybody is good with this role, right? I generate my subnet mask. The first thing. Okay. After that, in that subnet mask, I will find a weird number somewhere, right? So subnet mask usually we worked with, it's 255 or 0, right? But now we are dealing with a new subnet mask that they can be 192, 224, 240, 248, 252, something like that. Okay, I will take that weird number. Is it here or here? It can be here or it can be here or it can be here, depend the slash, right? Now 26, it's in the first position. So what I'm gonna do, I'm gonna take 256 always, right? This number never change, minus 192. Okay. So 256 minus that weird number. If it was, for example, here slash 27, I will end up here with what? With 224. Right? I will do minus 224. As simple as that. Right? Slash 28, I will end up with 240. I will do minus 240. Okay, I always take that weird number in there and do 256 minus that number. Okay, let's go to our example here. 26, 192 minus 192. I will find the number, like in our case here, it's 64, if I'm not mistaken, right? So this 64 here, or the number that you're gonna find, it have a name, right? This number is named the block size. Block size, sorry. The number that you're gonna find when you do 256 minus that weird number, different than 255 and different than 0, that you have in your subnet mask, the number that you're gonna find, it called block size. Block size, right? Now, what this number is needed for? Your block size, you're gonna use it to increment from one subnet to another one. And every time you're gonna increment, you will find a next network ID. That's it. It's as simple as this, right? Every time you will increment this number, you will find what is the next network ID. Okay, like for example here, if I take the first address, the general one, 256.0, right? And I will increment with the 64. I will find what is the next network ID. So this is the network 0. This is the first network ID, network 0, right? This is the this is the number that I have to increment, where I have to increment. Now we have another role, right? We have another role. We increment in the position of that weird number in the subnet mask. As you can see, 192, it's not here, it's not here, it's in the 4th position. So this is the position of my incrementation on the address. All right. So here it's going to be 64. And after that, increment again I will end up with 128. And I will increment again. I will end up with 80, 92. And increment again. I will end up with 250, 256. So I would take 255. Right. This one plus 64. Right. So this is all my network IDs, one after one. I don't need to go and do bits now and 0, 0, 0, 0, 0, 1, 1, 1, 1, 1. Not at all. Right. So all you need is to subtract 256 from that weird number in there. You will find your block size, increment with the block size, and you're good with. So calculate the IP range of the third. Right. So this is the first. This is the second. This is the third. So the IP range, I already have a network ID here. So the network ID is 192.132, sorry. 32.156. And the third network ID is 128. So the first address available is 120.29, right? And it goes to, I need to find what is the last address, right? So I need to find what is the last address. Here is telling me IP range, so the valid addresses that I need to have. So my network ID is 128, and this is the first address available. It's just the incrementation, the address after. Now I need to find what is the broadcast address of this range. So you see 192 is not the broadcast of this range, it's the next network ID. So the broadcast of this range here, right, is the address before this one. So here the broadcast will be 1991. Okay. So if the broadcast is 191 minus 1 again, I will end up with 190. So here I can go from 192, 32, 156, 190. This is the valid addresses IP range. Of course, here I have a network ID 192, 32, 250. He didn't ask me to do that, but I will just put them here. So this one is a network ID. And this is the range. And this is broadcast. 191. Because 192 is the next network ID of the fourth, right? So this one here will be the broadcast address. So you see how quick we can get them now? We don't need to do all the bits. You see, I solved it and explaining to you, right? I can do it much, much faster. So I did it step by step to explain to you, but we can now solve these problems quickly. Okay, find the subnetwork mask corresponding to /15. /15. So I should be on class A plus, always guys, 8 plus 7 here. This is what I'm having, 8 plus 7. So I should have 255 dot something dot 0 dot 0. So it should be this or this or this, right? Because I have 8 plus 7 plus 0 plus 0. This is 15. This is equal to 15. 8 plus 7 plus 0 plus 0. So it's 255 dot something dot 0 dot 0. Here dot something, right? So it should be one of these three here. Now, how I can make the difference in between, what I have to do, I have to know what is this 7 bits mean, right? So if I go to my template, I deleted it. Well, we can do another one. So if I go to my template here, 1, 2, 3, 4, 1, 2, 3, 4. So Here I have 7 bits. 7 bits. So I need to know what is the sum of all these 7 bits here. Of course, it's 255 minus 1. It's 254. 128 plus 64, 192, plus 32, 224, plus 8, 240, 248, 252, 254. Right. So this is the right answer right here. Okay. Convert. This is easy, right? So we need to see which one going to give us the 23 here. And this is 60 plus 4, 20, and 23. So this is the right answer. Slash 23, this means this is the network part, and this is the host part. Right, slash 23. So I should have 23 bits for the network. Calculate the network ID of the 5th subnet. Good. Another one that it's interesting. Okay, so we can do it quickly. He's asking for the 5th subnet of something. Okay. Well, let's follow just the steps, right? Now we have roles. We have roles. We need to follow these roles. He's telling me I have 200, 12, 30, .0 slash 27. Okay, this is class C. So basically it was slash 24. Now I'm on slash 27. How many bits I borrowed? 3, right? 3. Repeat question 6. Seriously? This is just the number of bits, slash 23. Where is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20, 23, right? Well, I have one extra here. Oh, sorry. Should be this one here. This is one extra bit. You just count where you have 23 in this one, right? Sorry about that. There you go. Question 1. Okay, so this is 23 bits here. I did a mistake. I saw 3 bits here. Sorry about that. So this is 20 plus 3 bits, 23. Okay, let's continue this one. So slash 27, how many bits I borrowed here? How many bits, as Kamal Deep say? 3, right? So I pushed 3 to get from 24 to 27. All right, so it's 8 plus 8 plus 8. So this is my 24 plus 3. So this is 255, right? First roll. I need to know what is my subnet mask, right? This is the first roll. So I'm looking straight for the subnet mask. 255, 255, 255, 8, 8, 8. So each one is represented by 255 plus 3 here. 3 is 220, 24, right? So this is the first roll. I get my subnet mask. What is the second roll? Second roll is automatically 256 minus 224. And I will end up with 32. This is my block size. Where I do increment in my address, where is the weird number in my subnet mask? It's in the 4th field, right? It's in the 4th position. You see, it's not here, it's not here. So I need to increment my address in the 4th position. Okay, so it's 200, 12, 30, something like that, right? Yeah, 30.0. First one. 32. I'm incrementing, right? Incrementing. 64. 96. 128. So this is first, second, third, fourth, fifth. All right. So we already got the network ID of the 5th one. Here it's 128. Right. So if he told me subnet 0, subnet 4, if he told me subnet 4, the subnet 4, not the 5th, subnet 4. So this is subnet 0, this is subnet 1, this is subnet 2, this is subnet 3, this is subnet 4. All right, so don't be confused with this. So if he told me what is the network ID of the subnet 5, I need to go one more extra here. right? Fifth subnet is first, second, third, fourth, fifth. Not complicated. Okay. But if I count the 0 with the numbers, so this is subnet 0, this is subnet 1, this is subnet 2, subnet 3, subnet 4, subnet 5. I need to go one more extra one here, right? Okay. So find the valid IP address range of the last network subnet. Subnetwork here 123. I will show you a trick here. I will show you a very, very useful trick. Please focus. It's very, very useful to use it, right? In this case here, the answer will be very, very easy. The answer will be very, very easy here. I don't need even to calculate anything. So when you deal with this word here, the last, right? When he say, what is the last one, right? See, find the valid IP address range of the latest one, right? When I deal with the latest, it's always that weird number that I find in the subnet mask. It's the network ID always of the last one, right? For example, I will explain myself. We have 123.0.0.0/14, right? /14. Here I have 8 plus, how many I have to add to 8 to get 14? 6, right? So I have 6 extra bits. So 8 plus 6. So my subnet mask will be 255, and this plus 0 here, right? Plus 0 plus 0. So my subnet mask will be plus 6 here, right? So 40, 48, 248 plus 4, it's a 252.0.0, right? 6 here. So I will just go to the template. It's easy. So I'm taking now 6 of them here, right? So I have 240 here, 248. This is 5 bits, 248, 5 bits, plus 4, 248 plus 4, it's a 252. So this is my subnet mask. First step solved, right? So I get my subnet mask. Now I can go and do stupid things. I can go with 256 minus 252. Oh, if I figure out that is 4, right? And I will start incrementing. Where I do increment now, you see the weird number is on the second position of my subnet mask. So I need to increment here. .0, .0, .0, 123.4.0.0, 123.8.0.0. This is all my network IDs. You see, I jump from 1 to 1, but it's gonna take a long time to do all that, right? He's asking the latest, the last one. The last one will always be this weird number here on the incrementation spot. Okay, so the last one, the network ID of the last one, will be always the weird number on the incrementation spot. So 123.252.0.0. This is the network ID of the last one. If I keep going and take like 1 day or 2 hours incrementing, keep incrementing, I will figure out that the last one is this one. You're going to find that the last one is this one. So it's a shortcut, right? I'm giving you a shortcut. When you deal with those kind of questions, even in the CCNA exam or whatever, latest, the last one, the whatever one, you just take that number and you put it in the incrementation spot, and you're good to go with the network ID. So my network ID should be this or this. I already eliminated 2 of them, right? So which one is the most correct one now, right? So I can go from here till here, so 255, 255, 254, or 255, 52, 255, 254. So which one is correct, guys? The first or the third? This is the last one, right? This is the last network. So I should go tell the last probability from here. From this network ID, I should finish all my probabilities because this is the last one. So what is the right answer? 1 or 3? People are saying first. Good. It's the first one, right? It's the first one because the first one I will go tell the last probability. I need to increment this after. What? All the whole network probabilities of addresses will end up here? 250, 52? No. You see, I increment from 0 to 4, from 4 to 8. Now from 254, I have to add 4 again, right? From 252 plus 4, I will find 256. But I can take it. 256 doesn't exist, so I will just take the one before it, right? So if I increment this one, I will finish in the others 255, 255, 255. I can't go 25600. It doesn't exist. Okay, because I'm working in 1 byte, and byte maximum is 255. So this is the right answer, guys. Right. Calculate the network subnet mask of the /19. Well, easy. /19. How many bits I borrowed here? So I were on 16 and now I'm on /19. How many bits did I borrow? 3, of course. 3, right? So 19 is 8 plus 8. It's going to give me 16 plus 3. So the subnet mask is 255. 255. Each 8 is represented by 255, right? And the 3 is represented by 220, 24. 220, 24. 128 plus 64 plus 32. I will end up with a 224 plus dot 0 here. This is my subnet mask, so I need just to look for it here somewhere. 24, the first one, first question. Okay. Calculate the IP address of the first subnet, or the IP range. Sorry, of the first network. /14. It's easy. We already did it here. Right, we already did it here, /14, and he's asking to calculate the first range. So the first range start with 128. So you see, I already have the first network ID and the second network ID, right? So I have network ID 0, network ID 1. Okay, he's asking for the first one, this one here. Okay. Now I already have the network ID. The network ID is 123.0.0.0. So the first address should be .1 here, right? I already find the first address where I'm gonna start. .0.0.1. Now, to be able to find what is the last address, I need to find what is the broadcast of this range, of the first one here, right? And to find what is the broadcast, I need to see what is the next network ID. So the next network ID is 400. The broadcast is the address that is just before this one. I can find the broadcast of my first network, right? So the broadcast before the network ID of the second network, it's gonna give me the broadcast address of the first one, right? So if I take this address, focus here, focus please, it's important, right? 4.0.0. If I do -1 to this address, what I'm gonna find? Which address? Which address is before this one? Come on, show me that you are smart. Which address is before this one? 123.4.0.0. Which address is just before this one? Good, Malhar. Perfect, right? So the address before this one is 123.3.255.255. Because if I increment this one, it becomes 0. 256 here plus 1, it becomes 0 again. and I increment the last one. Remember, seconds, minutes, hours, right? Same principle. But here we are not dealing with 60, we are dealing with 256, right? So the address right before the 123.4.0.0 is 3.255.255. So I already find the broadcast address of my network, of the third network. If I want to find the last one, it's easy now, -1 again, .3.255.254. This is the address just before this one, and this one is before this one, right? So this is the last address of it. So I need to see where is my starting and where is my ending here. 123.3.255.254. There we go. All right, so that was the last question here. Hope you get it, guys. I'm going to give you more exercise. I will give you one looking exactly like this one, but now you use the method of the block size directly, right? And I will give you another exercise also. So I will open those in Moodle very, very soon. Okay, so we have Subnetting 2. And tomorrow we're going to do the first chapter. We're going to talk about Wi-Fi tomorrow. And after I will give you much more complicated exercises with subnetting, right? That we're going to correct next weekend together. Okay, so more training on subnetting tomorrow coming. More complicated ones, right? Subnetting number 2. Subnetting number 2 is almost the same as subnetting number 1, just different numbers. There you go. It's lab 8 subnetting, something like that. So if you open it, you're going to find almost the same questions, but with different configuration here. So you will train yourself. Now we solved it together, right? So it's almost the same questions, but with different numbers, right? So just go with that logic again to practice more, okay? To practice more. So this one is easy. And after you have another lab is called troubleshooting. On troubleshooting, you have some problem to troubleshoot with subnetting. There you go. Here he's giving you 3 topologies, right? He's giving you 3 topologies. See, 1, 2, 3. You don't need to do that in Hyper-V or whatever, right? You just answer on the Word here, right? On the Word document. He is saying that PC2 is able to communicate with PC1. So you see, when we did this, this is all the configuration of each computer, right? So PC2 is able to communicate with PC1. PC2 is able to communicate with PC1, but not with PC3. Find a right solution. Find the right solution, sorry. That was Google translation. This is why, right? Because I have the same versions on French. So find the right solution here. PC2 is able to communicate with PC3. Now we have PC2 is able to communicate with PC3, but he's not able to communicate with the PC1. Find the right solution. Oops. So find the right solution here. Why? What we can do? What is the mistake here? He's giving you these addresses. All are subnets or not? Maybe, I don't know. Right? See, 194 subnet mask is weird. Here is class B. Look at the default gateways. Look at whatever, and see why the communication is able. Be careful here, right? Be careful. Huh? Sometimes you see the number was hidden. Just make it bigger, right? So be careful. Be careful with the document here. It can trick you. Please be sure that you can see all the numbers, right? Be sure that you can see all the numbers. You just open it a little bit, and you will be sure that you are seeing everything inside. Okay. Otherwise, you can do a mistake because of that. The third topology is PC1 is able to communicate with PC3. Now, this one is able to communicate with this one. but this one is not able to communicate with this one here, right? Why? Find the right answer or the right solution. Okay, so this is your exercises that you have to do. Tomorrow we're going to talk about this those two labs together also. We're going to correct this. We're going to do first chapter. We're going to talk about Wi-Fi tomorrow, right? So we're going to talk about wireless things. It's a small chapter. It's not complicated. A little bit of history, the principle of the waves, the electromagnetic waves, the ranges and those stuff, right? The antenna. We're going to talk about antenna also, the kind of antenna that we have, the again the Omni one. When we have to submit these two exercises today. We're gonna correct them tomorrow. It's nothing. Just questions, right? And we still have time. It's 11. It's 11:21. You type it. What did I type, Sheikh? What did I type?